Alright, so based on the name, people, based on the name of this lesson, what do you think we're going to look at today? What do you think that means? Any idea? None at all? Not even a good guess? What was that? Cones. We're going to look at cones today. That's where you get the word conic from, right? So, but we're not going to look at cones, the whole cones. We're going to be looking at what? Which means we're going to do what to it? Cut it, okay? So we're going to look at conic sections. Out of a cone, when you cut it up, you get three different figures, okay? Three different conic sections out of it, okay? So we're going to, everybody knows what a cone looks like, correct? All right, so it looks like it's an aspa cup, okay? And we're going to be cutting it up today. So let's start with cutting it up horizontally, okay? So if I take a cone and I cut it horizontally, okay? When we cut the cone parallel to the base, so that's horizontal, basically, what shape do you think we're going to see? A circle. We're going to see a circle, okay? Now, circles have a center at h comma k, so it's a point. They have a center at h comma k, and of course we all know that circles have a radius of r. And this is the general equation down here. This is the general equation for a circle, okay? So x minus h parentheses squared plus y minus k parentheses squared equals to r squared. X minus h parentheses squared plus y minus k parentheses squared equals to r squared. So I'm going to give you some time to kind of look. All right, so based on this equation here, tell me what you kind of notice from it. Tell me what you notice. Well, it has an x and a y. They're both being what? Squared. They're both what? Adding, okay? And it's always equal to r some. So I'm telling you right now, r is a number, okay? I know it looks like a variable, but r is a number. It has to be, right? Because it's an actual measurement. It's an actual measurement. Everybody knows what the radius is, correct? Okay, it's a distance from the center to the edge of a circle. So, and then it says it has a center at h comma k. So basically, guys, you should be able to see the center of the circle just based on the equation. Because whatever it is, x minus something and y minus something, those somethings are going to be the center of your equation, right? So you should be able to say, oh, I can graph this because I know where the center is. I do know how long the radius is. And remember, if the radius is 4 to the right, then it's also 4 everywhere around, right? Because that's the whole point of a radius, okay? So that's our first conic section. If I cut it horizontally, if I take a cone and I cut it horizontally, I get a circle, okay? What if I come at the cone at a slant, okay? I come at it what I call obliquely, okay? Obliquely. If I come at it obliquely at a slant, I get a different shape, okay? If I come at it obliquely, I get a different shape. Does anybody know what this shape is called? So it's circular, but it's not a circle, right? What can you tell is the biggest difference between a circle and this? It's what? Good. So a circle is the same where? All the way around. This is called an ellipse. Okay, so we don't call them ovals. Ovals is for first graders. Okay, ovals are for first graders. So they're not called ovals. They are called an ellipse. Okay, so never want to hear the word oval in a pre-cal class. It's an ellipse. So again, the biggest feature of an ellipse is, hey, it kind of has two radiuses, right? One is longer than the other. It's always one longer than the other, okay? So we have a horizontal axis and a vertical axis, we say. Because I know I have a length that goes horizontally, and I have a length that goes vertically. I'm going to call the horizontal one A, and I'm going to call the vertical one B. Okay? You realize that this other side is also the same length as A, right? And this other down here is also the same length as B, right? So I end up with this equation. Does it kind of look like a circle? A little bit. What do you notice? The equation itself. Does the equation itself look like a circle? Good. If you notice, take away the division. Isn't that basically a circle equation? X minus h squared plus y minus k squared, right? It's basically a circle. And which kind of makes sense because this is circular, correct? The only difference is now that they are divided by something. Each one is divided by something. So I do want you to kind of pay attention to X is always associated with the A. So this is always your horizontal, right? And B is always associated with the Y. So it's always your vertical axis, okay? A is always half the horizontal axis. B is always half the vertical axis, okay? And biggest, most important thing is this. It's always equal to 1. 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 Okay? If it's not, then we're going to have to fix it, okay? So, if it's always equal to 1, ellipses are always equal to 1. Ellipses are always equal to 1. So, again, if you notice, they're basically a circle that's being divided, right? It's being divided, which means that it's not the same all the way around. Okay, it's not the same all the way around. It has different lengths on both sides. There are actually two kind of ellipses. Okay, there's the one that I showed you here, and if you think about it, there's an elongated one too. Okay, so there's one that's more shaped like that. It's still an ellipse, but this time, what can you tell the difference? It's more vertical, right? It's more vertical. So the B is longer than the A this time, and that's okay. We'll get that too. Okay, so you have basically two ellipses. More of a horizontal ellipse, it's longer horizontally, and then or a vertical ellipse where it's longer vertically. So I've already cut a cone horizontally. Okay, I can cut it slanted, and can you tell that no matter how I slant it, it's still going to be an oval, right? So there's one more cut for a cone. What do you think? Straight down, a vertical cut. Okay? If I cut it vertically, so imagine I come at a cone from the top. Okay? I come at a cone from the top. What shape do you notice? So it looks like this. It's not a triangle because it curves. It's a parabola. Okay? So a cone, when you come at it vertically, so we're basically cutting the cone perpendicular. Ooh, there's a geometry word. You guys remember what that means? What does perpendicular mean? Good. So 90-degree angle. So the base is flat, right? The base is flat, so the cone's sitting flat on your desk. And 90-degree angle means I'm coming straight from the top. Straight from the top. It has to meet at a 90-degree angle. So straight to the perpendicular to the base, we see a parabola. So, well, that's good. We know about parabolas, right? We know parabolas have the same kind of vertex, right? That top part, that vertex, at h comma k. And then their equation looks more like this. Y equals x minus h squared plus k. Where, again, this and this, the h and the k end up making your vertex. Okay, so I'll give you a couple seconds to copy that. Alright, so the biggest thing, guys, are the equations. The equations are the things that make all the difference. So, right now, we have 3 different conic sections. What are they? What are the sections that we get from a cone? First one was a circle. Second one was an ellipse. Third one was parabola. So each one of those has an equation. And based on the equation, we should be able to tell right away, oh, That's a parabola. That's a circle. That's an ellipse. So look at this equation for the circle. What do you notice? What's the big features here? So they're both being squared, and more importantly, they're both being added on the outside, right, between the two, and it's going to be equal to a number, right? Probably a large number because it's going to be squared. So however long the radius is, it's going to be squared. So it might be a large number, right? What's the big features from the equation of an ellipse? The divided by, and more importantly, it's equal to 1. And what's the big features for? It's y equals. Very good. If it's just y equals, and then only your x is squared, odds are it's a parabola. Okay? So, let's see if you can do this. Given this equation, so here you go. Tell me what it is, and tell me if you can see the center, and tell me if this has any special features. So, I have parentheses x minus 3 squared plus parentheses y plus 5 squared equals to 16. For the most part, yes. When it gets more difficult, I might mix it up. Because think about it. If it's squared, couldn't I actually square this out and tell you x squared minus 6x plus 9, right? And you should be able to factor it and put it back in this form. So eventually I'll get there. But for now, we're baby steps, right? So guys, just on the equation alone, can you tell me what this is? This is a circle. Very good. Does everybody agree with him? Okay? This is a circle. Can you tell me where the center of this circle is? Where? Which one's that? Which one's which? So remember that the center is h comma k. So, you're kind of right. Look at your general equation. Isn't your general equation like this? Right? So h is exactly what this is. As long as it's subtracting, you just take the number. Right? So what's my h? Just 3. But then this one, notice that it's adding. So it's actually, if it's supposed to be subtracting, but it turns into adding, what happens to k? It was a negative. So my center is actually at negative 5. Everybody got that? Yeah, I mean, it can, obviously, it can be positive, but when it is, you're thinking opposite of the actual numbers. Does that make sense? Okay? So is everybody good? I know it's a circle. I know it has a center at 3 comma negative 5. Tell me something about this circle. Tell me about this circle. It has a 3 and a negative 5. But if it's a circle, you got to tell me one more thing about it. I need to know how long the radius is. I need to know how long the radius is. So now, look at your equation. Your equation says it's r squared. But notice, it just says 16. So is this 16 squared? No, this is actually 4 squared is 16. So then what is the radius? Just 4. So this has a radius of 4. Does that make sense? Do you see how I did all that just based on the equation? Based on the equation, I could say, oh, it's a circle. Here's the center. Here's how long the radius is. And do you see that now that I know this, I could graph this if I wanted to, right? Like if I had a graph, my center is at 3 comma negative 5. So where is that, by the way? Where is 3 negative 5? To the right, how many? 3. Let's see if we can remember how to do that. 3 to the right, down 5. 1, 2, 3, 4, 5. So bam. There's my center. And now how do I draw the rest of it? I mean, kinda, but I gotta be a little bit more precise than that. What does a radius mean? Meaning that it's 4 where? Everywhere, every direction. So what I would say is, oh look, just go 4 from the top, 4 from the left. So 1, 2, 3, 4. 4 from the bottom, 1, 2, 3, 4. and 4 from the right, and then try your very best to make that a circle. That's not a very good circle, but you have graph papers, so yours should be a little better. But do you see how I did that, right? So it's a circle. I know it has a center, and I know that the radius is the same length all the way around, correct? So give yourself a good general idea. Okay? Let's try another one. So here's your equation. It's x plus 2 squared plus y squared equals to 100. X plus 2 squared plus y squared equals to 100. So, can you tell me what you think this is? What? You think it's a circle still? What makes you think that? Good. It's not divided. The other one's a y equals. So does everybody agree? It is a circle. I'll tell you that. It is a circle. Good job. It is a circle. Can you tell me the center of this circle? -2 and 0. Okay? Now, how do I know that that's a 0? Because you're not subtracting anything, right? You're not subtracting. Do you agree that I could, if I wanted to, write this as y minus 0 squared? And it would be the same thing? Right? So you don't just throw a number there. Don't just think it's 1. It's minus something. And if there's nothing, then the number is 0. And can you tell me something special about this circle? Good. The radius is 10. The radius is 10. Where did I get that from? Because 10 squared is 100. Now, I'll tell you right now, do all circles have perfect squares as radius? No. So sometimes there's going to be a number that you can't perfectly square, right? Like, for instance, so everybody good with this example? But what if I told you it was equal to 23? I don't know. Good. Then that means the radius is the square root of 23. Okay? Does that make sense? Right? Because you can't, I mean, if you can square root it, fine, perfect. Then it's just a whole number. But if it's not, then it's just the square root of that. And then you can tell me, like if I asked you to graph it, you could say, oh, that's approximately, what is that going to be? 4 point something, like 4.4 something. You guys aren't checking, so I can put whatever I want. And you'll believe me. Okay? So, you see what I'm saying? And so you could graph, and you could be like, I was off. How off was I? What is it? That's what I said. Y'all aren't even paying attention. Okay? All right, so I just want to let you know. So you're not always going to get a perfect square there. Okay? So don't freak out when you finally do get one. All right, we're doing pretty good. Let's keep going. Perfect. You saw it right off the bat. Okay? So automatically, you can tell that this is an ellipse. How? Because it's dividing, and it's equal to what? 1. Good. Okay, so give me a second. So this is an ellipse. Everybody good with that? Okay. So this has a center where? Everybody agree with that? Everybody good that far? Okay. Now, the special features are the horizontal and the vertical axis, right? Because I got to know, is this a long ellipse or is this a tall ellipse, okay? Is it long or tall? So the way I tell that is based on my A and B. Now, if you remember correctly, this was x minus h squared over a squared, and this was y minus k squared over b squared. So it's kind of like the same thing as a radius, right? So A is how much? 3. So A is 3, and B is what? 2. So remember, A represents the what? Which direction? Horizontal. So this is the horizontal axis. And B represents the vertical axis. So could you tell me, is this wide or is this tall? I'm sorry, is this long or tall? How can you tell? So this is going to be long, right? It's going to be long because the horizontal is longer. And you could actually, again, we could give ourselves a little sketch here. How would I graph this? I know it has a center at what? So then that's, how do I get there? 1 to the right, 2 down. Bam. So there's my center. And according to my center, I know my A, which is my horizontal axis, is what? 3. So 1, 2, 3 right there. Remember, and that means it's also both directions, correct? So then that's 1, 2, 3. I know my B is my vertical axis, which is 2. So 1, 2. And then 1, 2. So this should look kind of like a football. If that, close. Okay? It looks like Stewie Griffin's head, right? So now you know, when you watch Family Guy, you're all going to see Stewie and you'll be like, that's an ellipse. That's an ellipse. Okay? Any questions? We good? All right. Try again. This should be easy too. What is this one? Why? So this one screams parabola because it's y equals. Okay? Y is by itself, and then it's equal to something, right? So can you tell me, according to this parabola equation, can you tell me where the vertex? Now, remember, parabolas do not have centers, right? Because they're not enclosed. So they don't have centers. They have a vertex. They have that part, that one particular starting point. Can you tell me what the vertex of this one is? -7? It's 7, right? Because remember, it's x minus h, right? And then this one is... So if you look at your equation, your general equation, it looks like this. X minus h squared plus k. It's -9. So this one's tricky. Because so far, all we do is we take the opposite of this number, right? So it looks like it's a -7, but it's really a +7, right? But then notice, what's the difference? It's actually pretty good. This one's not being squared, and more specifically, it's not inside of parentheses. So when you're inside of parentheses, you think opposite, right? When you're inside of parentheses, think opposite. When it's not in a parentheses, when it's outside, you take it as is. Yep, it stays the same. So outside of parentheses, people, just take it as is, okay? So then this has a vertex at 7, 9. And there's one more thing I kind of want you to tell me about this parabola. Does it have a minimum, meaning does it open upward, or does it have a maximum, meaning does it open downward? And it's actually pretty simple to tell. Simple as that. So there's a number here. Does everybody see it? What is it? 1. Is that number positive or negative? Good. So then that means that this thing opens up, which means it has a minimum. Okay? So this has a minimum. Okay? Does everybody see what I looked at, right? You just look at the front. And now a lot of you in your heads are like, sir, there's nothing there. Yes, there is. There's always a what? There's always a 1. Okay? Because remember, you can multiply 1 by anything and it's not going to change anything, right? Well, how would it look like if it was a -1? I would literally have to have a negative there, right? So then you see the difference, right? So +1 means it opens upward. So basically, does everybody agree that this looks like this somehow? Okay? And so therefore, it has a minimum. If it had a maximum, it would go the other direction. We good? All right. All right, so now I'm going to switch it up on you. I'm going to tell you the shape. I'm going to give you the center and the special features. Now I want an equation. So before I gave you the equation, and you could break it down, but now I'm going to give you the breakdown, and I want an equation. So this time, I want an equation. I want an equation of a circle with a center of -5, 2 and a radius of 9. A circle with a center of -5, 2 and a radius of 9. So your first step is to, okay, first of all, what is the general equation for a circle? Everybody agree with that? So that's what it should look like. Everybody should know what it looks like. Okay, do I have all the information? Yeah, I know. What does this represent? And obviously this is my R. So, based on that information, you should be able to give me the equation. Why is it plus 5? Because if it was minus a negative, it turns into plus 5 squared plus y minus 2 squared equals 81. Why'd you get 81? Where'd you get 81 from? Because good, remember it's r squared, which is 81. So can y'all do that too? So now I can give you the features, and you should be able to give me the equation. Like what? It's kind of hard. Like for this stuff, I have to pretty much give you everything. Okay? When we get into later, I'll give you more complex stuff, but it's always you have to be able to find that information. Okay? So it's never like I just straight up don't give you anything. Okay? Can everybody do this? That's simple, right? Okay, let's try another one. Let's try another one. Let's try another one. So this time, I want an ellipse centered at 4, -3. Okay? With a vertical axis of 10 units and a horizontal axis of 6 units. With a vertical axis of 10 units and a horizontal axis of 6 units. So I'll give you a second to write that down, and then we'll talk about it. Alright, so I want an ellipse with a center of 4, -3, vertical axis of 10, and a horizontal axis of 6. So, guys, give me the general form for an ellipse. Okay? So that's what it should look like. So so automatically in your head you saw ellipse, and hopefully you're thinking, okay, this is the one with the division. This is the one with the division, and it's the one that's equal to 1. Okay, so bam, I already know what it's equal to. Okay, I already know what it's equal to. I know I'm dividing. So now let's just fill in the rest. Okay, so obviously this is my h and k. So tell me what the top of the first one looks like. X minus 4 squared. And then here it says that, which one's this one? Is this my horizontal or my vertical axis? How do you know? It's actually a little bit of common sense. Isn't X your horizontal axis and Y is the vertical? So that makes sense that this is with the horizontal and this is with the, right? Okay. So it says I have a horizontal axis of 6. So that means that my A is equal to 6. So then what number is going to go here? 36. Remember, it's A squared. So it's 36 that goes there. So then the other side, it's going to be what? Y plus 3 squared. And it tells me that my vertical axis is 10, so my B is 10. Therefore, this is going to be 100. Fantastic. Fantastic. Any questions so far? Okay, a few more. Let's practice graphing. Okay? So now this is where the graph paper is going to come into play here. Okay, so let's practice graphing a circle. So, I give you the equation, you should be able to give me a perfect graph. Okay, so before I even start drawing, the first thing I'm going to do is, what do you think? Well, figure out what it is. So what is this one? This one's circle. Why? Not dividing, not y equals. So it's got to be a circle, right? It's got to be a circle. Can you tell me something about this circle? The center is what? Everybody got that? And what's the radius? Where'd you get that from? Okay, so if it's equal to 16, then that's r squared, right? You square root it, you get 4. Now, wait a minute. Didn't I spend like all last couple weeks telling you when you square root, you get two answers, a positive and a... So then why are we completely ignoring the negative here? You can't have a negative length, because remember, radius means a length, right? Can you have a negative length? So it's impossible, okay? Exactly, there you go. If you want to get into that, we'll talk about that later, right? So I know it's a circle. I know I have my center. I have my radius. Basically, I broke it down. Now just draw it, okay? So where is my center? How do I get there? 3 to the right, 2 down. So there's my center. And then this one has a radius of 4. What does that mean? 4 in every direction. Okay, 4 in every direction. So 1, 2, 3, 4, bam. 1, 2, 3, 4, bam. 1, 2, 3, 4, bam. 1, 2, 3, 4. And then try your very best. Close enough to draw a circle. Okay? No. Any questions? We good? Too easy, right? Let's try graphing an ellipse. Okay? Let's try graphing an ellipse. So, I know it's an ellipse, besides the fact that I told you let's graph an ellipse. But secondly, how do I know it's an ellipse? It's dividing, and it's equal to 1. Thank you. So it's dividing, and it's equal to 1. So just like the other, let's break this one down, okay? What is the center? And tell me what the A is. And what's my B? And again, what does the A represent? Horizontal. What does the B represent? How do you know that? Good. A is with the X, and B is with the Y. A is with the X, and B is with the Y. Okay? So, go to your center. 1, 2, 3, 4, 5, negative 1. And I knew this was going to happen. So, from here, what's going to happen? Which way is A? To the left and to the right. So I know it's 1, 2, 3. And 1, 2, 3. I'm out of room on mine, but you shouldn't be. You should be okay. And then I know my B is 1, 2, 3, 4. 1, 2, 3, 4. So what kind of ellipse is this? It's a, wow, that's really bad. Let's just pretend that didn't happen. Cool. A little bit better. So this is a vertical ellipse, right? It's taller than it is wider. It's taller than it is wider. I have students that say, sir, but what if they're the same? What if it's the same tall as it is wide? What? Then it's a circle, right? Then it's a circle. Any questions? You sure? So then you call it so what if it looks like the equation of a circle? Right? But I'm sorry, what if it looks like the equation of an ellipse, but it's a circle? So let me show you what that would look like. Yes, it would. So it would look like this. Let's just say it was x minus 5 squared plus y plus 1 squared. Let's just say over 9, both of them, right? And still equal to 1, right? And then you could say, you could be like, well, wait a minute. I know they're the same, so I know it's a circle. So how do I make it look like a circle? It's actually pretty simple. What if you multiplied everything by 9? So that would cancel that out. That would cancel that out, and then this would become a what? So then now it's a circle. Okay? So I can't do that here because if I multiply this by 9, it's not going to go away. It's just going to get bigger, right? So keep that in mind. All right, last one. Let's try graphing your parabola. This is going back to algebra 1. Okay? So, but it's easy now because I make it easy. Okay? So, besides the fact that I tell you it's a parabola, how do you know it is a parabola? It's y. Wait, it doesn't say y, it says f of x. That is y, right? So this is y equals blah, blah, blah. So, shh. Tell me something about this parabola. Yes. How do you know it has a minimum? Because it's positive. So when you say it has a minimum, what are you really saying? Good. It opens up. Okay? So it opens up. So that's important. What else can you tell me about this? Or what's more important? I got to know what? Parabolas don't have centers. What do they have? They have a vertex. So I know what you mean. But for parabolas, it's called a vertex. What is the vertex of this one? 2. Are you sure it's not negative 1? Good. Remember, when it's outside of parentheses, you take it as is. Okay? So this has a vertex of 2, 1. And I know it opens up. So it's pretty simple, guys. It's pretty simple. So 1, 2, 1. And I know it opens upward. And here's the thing. So students are always like, so what do you want, sir? Do you just want me just to draw it like that? I mean, you kind of could. But if you want to be a little bit more precise, remember, parabolas are symmetrical, correct? And you know it's going to just get bigger. So I would say, oh, there's that one. There's that one. You know what I mean? Just kind of make it to where it's symmetrical. And I'm fine. And it's not supposed to be that pointy either. But you know what I mean. Okay? So here we go. This was our intro to what? Conic sections. Why do we call it conic sections? Because all these come from what? A cone. All these come from the cone. When I cut a cone. So there's 3 different ways I can cut a cone. I can cut it horizontally, and when I do, I get a circle. I can cut it slanted. What do I call it? Not slanted. I don't call it slanted. Obliquely. When I cut it obliquely, what do I get? An ellipse, not an oval, an ellipse. And then when I cut it vertically, what do I get? A parabola. Got it? Any questions? So this is simple because it's called an intro, right? I'm just kind of saying, hey, this is what we're going to be doing.